Hey guys, I'm the Hacksmith, and on this episode of Make It Real, we're going to try and make a real arc reactor, since it's been one of your most common requests. So what exactly is an arc reactor? Well, it was first introduced to the MCU in Iron Man. And just looking at it, it looks like it produces a continual arc of electricity in a loop, and somehow that generates power.
Infinite power.
To me, it kind of looks like a perpetual energy device, which we know is impossible because the most fundamental law of physics is the conservation of energy, which states that energy in a closed system is constant, which means energy cannot be created, only transformed. That simplifies into an equation: energy in equals energy out plus losses, usually in the form of heat. Because of the second law of thermodynamics, we know there are always losses. Always. Which kind of makes sense when Obadiah says this.
The arc reactor, that's a publicity stunt.
It's a publicity stunt. It's a publicity stunt.
We built that thing to shut the hippies up.
It works.
Yeah, as a science project.
But then, in the cave, when Tony miniaturized the arc reactor, he uses palladium.
What is that?
That's palladium, 0.15 grams.
Which suggests the arc reactor might actually be nuclear technology, since some palladium is radioactive. Unfortunately, it's also highly carcinogenic and toxic, so I'm not about to play with palladium for a fictional technology. Now, the power output specified is also kind of ridiculous.
But what could it generate?
If my math is right, I don't know what it is, 3 gigajoules per second.
A joule per second is just a fancy scientific way of saying a single watt, which means the arc reactor produces 3 gigawatts of power. That's almost 3 times the power output of a time-traveling DeLorean from Back to the Future.
But I need a nuclear reaction to generate the 1.21 gigawatts of electricity.
1.21 gigawatts!
In fact, if we were to sell that energy back to the power grid the same way I sell solar energy from my roof, it would be the equivalent of 833 kilowatt hours, which would generate $250 per second of income, or $21.6 million per day. Basically, if I were to invent a real working arc reactor, all of our funding issues would be solved, and we'd be well on our way to building a real-life Iron Man suit. Or, more realistically, our entire company would be assassinated by the big oil companies. So, it's pretty much impossible to make a real working arc reactor. So, let's build a real working arc reactor. Alright, now before we build the arc reactor, let's take a look at a 3D model using some augmented reality tech, not unlike Tony Stark himself. Pretty cool, right? Let's take a closer look. Now, it looks like the electricity is being generated in the final ring of the assembly. But I guess the real question is, if we're building an arc reactor, how are we going to do that? Let's get some paper out and actually do some calculations by hand. So, to sustain an arc of electricity around the arc reactor, we're going to need a lot of voltage. The diameter of the arc reactor is around 75 millimeters across, which gives us a circumference of around 241 millimeters, which would be the path the electricity actually has to follow. Now, it takes approximately 3 million volts to ionize air for an arc to form across a distance of 1 meter. That's roughly 30,000 volts per centimeter. So, with a 24.1 centimeter travel path, we'll need approximately 723,900 volts of electricity. Luckily, we have these little high voltage transformers which produce about 80,000 volts each. There's 10 segments in the arc reactor, so that would be about 800,000 volts. This might actually work. Let's start assembling it. Yeah. They do need to be close together, so I might thicken up that divider wall. Yeah, that'd be good. These wires get hot.
Smells nice.
Yeah, I don't know what that is. I think it might be acrylic, but most realistic arc reactor ever. Yeah, so these wires, they're not very thick, but like if they're next to each other, they don't arc, as long as there's something else there. So I'm wondering how thick the wires I need carrying the high voltage near my body. See, perfectly safe.
As long as you don't become the path of least resistance, you'll be fine.
Alright, now that we have most of the components assembled, we're going to have to control them somehow. I made a quick block diagram to explain how the circuit's actually going to work, but basically we're going to use a relay bank to control the outputs of each high voltage module using Arduino. The power input is from a lithium polymer battery. Now, we actually have a more detailed electronics diagram which you can check out using the link in the description below to visit our project on maker.io.
Battery is connected to all the wires.
Oh, okay.
This powers Arduino. And the relay boards.
It's ready for its first test. See, the most realistic thing about this arc reactor is the number of wires coming off it, because if it was actually producing that much electricity, you'd need some serious current carriers to get that energy somewhere useful.
Broke all that stuff.
Alright, so we've got the arc reactor all set up and we have a clamp meter to measure the current flowing through the wires as we do a startup sequence. 1, 3, 6, 8, 9, 10, 14, 20 amps! Alright, so obviously I don't have a hole in my chest, so I can't actually wear this arc reactor. So I thought it'd be nice to make a nice kind of like display case that we can use for when we're actually powering stuff using the arc reactor. Alright, so we've got the arc reactor in its box now, and we've actually got the switches on the box, so let's open it up. Alright, so main power is this switch here, and we'll try and do a startup sequence. Alright, let's see if it can power a phone. Alright, let's see what else is in power. Alright, so we're here at the main circuit breaker for my house, and we're going to plug in the arc reactor. Alright, let's turn it on and see what happens. Alright, so these are the power meters for the house, and as you can see, that's how many kilowatt hours we're using. Alright, let's reconnect it to the grid. Alright, so obviously it's not actually producing enough power to do anything useful, but it certainly looks cool and sounds terrifying. We'll be using it for some future gags in upcoming videos where we use it to actually power our projects. One of our goals here is to inspire people into STEM fields, to learn and create things themselves. We get tons of messages asking how we learn to do this stuff. And the answer is simple. I'm a problem solver. I'm not some kind of genius. I just like to learn and use those concepts to make cool stuff. I learn by doing, and that's exactly what Brilliant.org allows you to do. Brilliant.org is a problem-solving site that helps you think like an engineer by guiding you through the problems that bring you from knowing nothing to having a deep understanding of the topic. If you'd like to learn more about problem-solving and engineering so you can build stuff like this yourself and support our channel at the same time, go to brilliant.org/hacksmith and sign up for free. The first 200 people that go to that link will receive 20% off their annual premium subscription. Well, thanks for watching. Hacksmith Industries now has their very own arc reactor. Leave a comment below to tell us what other comic book tech we should recreate. Alright, let's see if it can power a phone.
Elena's not gonna touch it. No.